In this assignment, we'll be drafting an elevation detail of the most basic bungalow-style door from the arts and crafts era of historical design. If we utilize the layers properly, we should be able to use the door we complete here as the basis for developing several different styles later in the project. Let's get started with a file that has the following settings. Units are set in architectural units. The text, dimension, and multi-leader styles have been established for shop drawings, which is the category that most detailed drawings fall into. I will point out what makes these drawings different as we move through the simple drawing. The drawing that I will be demonstrating looks like this one. I will keep this illustration up in the video to use as a guideline for our drafting. The AutoCAD commands in this assignment include a review of the line command, offset, layer management, hatch, match properties, and linear dimension. Additional useful commands are rectangle, explode command, and the distance command for checking your work as you draft. Let's get started. The overall dimension for this door is 31 3/4 of an inch wide and 83 5/8 of an inch high. I use the line command to create the overall dimensions in red, but you could also use the rectangle command as you see me do here, and then explode the polygon into individual lines. The important thing to know here is that it will be easier to draft the rails and stiles of the door components if the outline of the door is composed of lines instead of being defined as a polygon. Once you have checked your work to make sure that the overall dimensions are correct by using the distance command, you can move on to drafting the rails and stiles. I will use the offset command and set the offset distance to 6 inches. I will pick the vertical lines to offset to the inside of the door outline to create the stiles. Stiles are the vertical panels that make up the door assembly. Change the stile lines to a different layer, such as I-elevation-medium. The heaviest line weight should be the outermost lines that define the overall door width and height. All other lines should be lighter as you work to the inside of the drawing outline. We'll be consistent about this practice through the entire assignment as we draft. Now use the offset command again with the same 6-inch offset distance to create the top rail, which is the horizontal panel that is located at the top of the door assembly. Use the match properties command to match the layer properties of the stile to the rail lines. Use the trim command to cut away the horizontal lines that overlap the vertical stiles. Use the offset command again, but this time set the offset distance to 12 inches for the bottom rail. Use the trim command to cut away the horizontal line that overlaps the vertical stiles. Use the match properties command to match the layer of the stiles to the rail. Use the offset command again, but this time set the offset distance to 39 1/2 inch to establish the bottom line of the intermediate rail. Use the offset command again, but set the offset distance to 5.5 inches to create the top of the intermediate rail of the door assembly. With the rails and stiles now in place, we can add the door hardware. You can create your own hardware or download a W block from a hardware vendor. To prepare for the door hardware, make the I-elevation-medium-light the current layer. Once you've downloaded the block that you're interested in using, you must insert it through the block's library. Choose whichever door, push-pull, and plate that you like best. When I reference the term push-pull, I'm actually referring to the hardware that most people call a doorknob or lever. Position the push-pull hardware by moving it to the midpoint between the stile and the outside edge of the door, as you see me do here. Since I know the width of the stile is 6 inches, I can use the offset command at an offset distance of 3 inches to find the midpoint. Adjust the location of the hardware by using the Move command. I will center the circle to the new vertical line. Now that we've established where the hardware is located in one direction, we need to figure out how the plate would be located vertically. To figure this out, you need to know the standard mounting height. Note that all measurements are established to their center lines. We do not place hardware to the edge of the plate, but to the center of the circle that represents the push-pull. I will use the offset command to create a horizontal reference line with an offset distance of 42 inches. Once I have the vertical and horizontal reference lines, I will move the circle of the push-pull hardware, which is the center of that circle, to the intersection of these two lines. Now, if you're wondering what my OSNAP or object snap is, right now I've splashed them up in the video. We are next going to add the wood hatch to the door panels. Change the current layer to the A-Pat layer. The wood patterns provided here are not part of the standard hatch library in AutoCAD. What I've done is borrow a hatch pattern from the project to share with you. Keep in mind that you can copy any hatch pattern from a previous assignment and paste it into the working drawing. This is how it works. Apply any hatch pattern from the library to the door panels. Then use the Match Properties command to match the copied hatch to the current drawing. Change the pattern angle orientation so that it corresponds to the correct presentation on the panels, meaning that the grain direction for the rails should be horizontal and the grain direction for the panels and stiles should be vertical. Continue to apply hatch patterns to the different parts of the door assembly. Use the Match Properties command to adjust the patterns on the door. To change the angle of the wood grain, pick on the hatch pattern, and the hatch dialog band will pop up again and let you modify the angle setting. From the hatch dialog band, you can also adjust the scale of the pattern. Increase or decrease the scale of the pattern so that it looks like the example illustration provided. Once you have the rails and stiles completed, the last part of the door to hatch are the panels. It is now time to add the dimensions. Switch the current layer to the A dimensions layer. Utilize the ANSI dimension style provided for this exercise. Creating the Shop ZZ dimension style is covered in a separate video. Dimension the door by following the illustration example provided for this assignment. Adjust any dimensions using the blue grips so that the dimensions look neat and organized like you see mine here. We are now going to make a copy of this door. Switch the current layer to Def Points layer. On the Def Points layer, draft a line from the bottom of the door and make the line 5 feet in length. By drafting the line on the Def Points layer, we can maintain equal spacing between the doors we create, and the line will not become part of the final print. It is a good idea to change the current layer back to a layer like layer 0 so that you do not accidentally draft on the Def Points layer. since anything drafted on that layer will not print. I will bring up the layer panel by typing LA at the command line. Since the copy will not need dimensions, we will turn off the A dimension layer temporarily. Now make a copy of the door. Place the copy at the end of the reference line we just drafted. Turn back on the A dimensions layer and make it the current layer. On the door copy, dimension the push-pull hardware location from the bottom of the door to the center line of the circle. Zoom in to each area for accurate dimensioning. Why did we make a copy of the door for the hardware placement instead of dimensioning it on the first door elevation? The reason is that each door illustration serves a different purpose. Our jobs as draftspeople are to provide clear instructions. The first illustration shows the dimensions of the door assembly, whereas the second dimension is just for the placement of the door push-pull hardware. It is okay to combine the dimensions into the first drawing, but in this case, since the fabrication will be done by two different craftsmen, it makes sense to have the tasks separated.